is due to the magnets, one is due to the reluctance. So here the reluctance torque is being used. So it is singly excited system. Sinusoidal currents are there, sinusoidal voltages are there, no protomagnets are involved. Efficiency is lower than the PMSM. Here reluctance torque is equal to developed torque, that's why it's a low torque machine and it has noisy operation. But if you include, instead of inserting PM, your PM assisted synchronous reluctance motor, then that will be a big advantage. So when we design electric vehicle, the first part is mechanical design, where we have to determine the tractive effort to propel the vehicle under given operating condition. So usually take the worst case scenario. And based on this, the mechanical design will tell you, okay, this much torque and speed are required. Based on the torque and speed requirement, we'll select the motor in electrical design. Based on the motor, power converters will be selected. Motor current and rating will help us in selecting the power rating of the current and voltage rating of the power converters. We'll select the battery pack. Based on the battery pack, the charger system is to be designed. Based on motor, battery, and a type of DC-DC converter, the control system is designed. And finally, we have protection system in the vehicle. So this is the mechanical design. So this is your electric vehicle moving on the road. So whenever a vehicle is moving on the road, certain forces are acting which oppose its motion. One is the F roll, that is the rolling road coefficient of resistance. The road is going to resistance between your wheels and a type of road. This resistance changes in sand, gravel road, cement road, ice, it will change. Then your aerodynamic drag is there, F air. Then when your car is moving on the gradient, that gravity is going to play a role. And most important part is mv into the A. This is mass into acceleration. So when your acceleration is there, this force will be form the significant part of the electric vehicle, the tractive effort required. And during acceleration, large power is required. That's why you want to shift from battery to the ultra capacitor during the acceleration part. So based on this data, you need to have the mass of the vehicle, the type of the tire you have used. Based on that, you'll get rolling road coefficient of resistance. And based on all this, you will calculate how much tractive force is required, the highest acceleration that your vehicle can provide. So now you know the tractive effort Ft. Based on the tractive effort, the force required to propel the vehicle, you can find out the speed and torque of the vehicle. So this is the formula you can get from, based on the radius of the wheel, you can get the speed of the vehicle in radian per second, speed of the motor rather, this will be used by the motor, and the torque required, Ft into R. R being the radius of the vehicle. Based now you know the torque and speed requirement of the motor. So you can select the motor based on the torque and speed requirement. Once you have selected the motor, you can go with the design of the inverter, the battery selection and other thing. So you have battery and some power electronic interface feeding a motor. So this becomes electric drive, right? So speed control of motor is involved, so electric drives are involved. So what is the electric drive? It is a combination of power electronic converter modulating the power being applied across the motor terminals, so that the speed torque characteristics of the motor can be matched with the load. Here our load is electric vehicle and the source is a battery. More than this, a sensor unit is there to measure various electrical and mechanical parameters for the control algorithm to be implemented through a controller. So let's have a look at the block diagram. So you have a supply. This is going to be your battery. You have mechanical load. If you are simulating your mechanical load, will be you have to calculate a tractive effort and provide the data, what type of road is there, what type of gradient is there. Based on that, you'll have the torque and you have the programmable torque, what you have loads, that you can insert the torque and speed. Then your electric motor, which is fed from the battery, is a power electronic converter, because motor will require variable voltage, variable frequency supply. Whether it's PM, BLDC, PMS or induction motor, you need variable voltage, variable frequency supply. So here your inverter and DC-DC converter. Again, see, inverter requires some switches, some activation function, the gating signals. So this controller will implement the control algorithm for speed control of motor and is for this control of battery, charging, discharging. But they require some feedback. So sensor unit will provide feedback. Let's say motor voltage, motor current, stator currents are there, stator voltages are there, speed is there, temperature will play a role in power electronics and motor. Then battery voltage and current, battery temperature. So all this will play a role. So this is a control structure, a basic control structure for any electric drive. So power structure remains same, what we had. Motor is being fed by a supply and interface by a power electronic converter. So sensor unit we have, which will sense the rotor speed, stator current, stator voltage, terminal voltage of the battery and motor, etc. So you have two loops, outer speed loop and inner current loop. Speed being a mechanical quantity, change in speed will be slower. Current will depend on the electrical time constant, which is in microseconds. This will be in seconds, variation will be. So this is the inner loop and this is the outer loop. So you'll compare your reference speed, the command, this will be based on the command given by the driver with the actual speed. There will be error. So now we will say, okay, this, so we have a common formula, that is TE, developed torque minus load torque, is equal to J d omega by dt. J being the moment of inertia. So rate of change of speed. So if your developed torque is higher than the load torque, my motor will accelerate. If your developed torque is lower than the load torque, my motor will decelerate. If my developed torque is equal to the load torque, my motor will run at steady state speed, at constant speed. That is the fundamental principle that is being used. So this speed control will process the difference between the two speeds, reference and actual speed, and determine how much torque should be developed by the motor so that the actual speed can match the reference speed. Okay, but the problem is now the torque sensor. The torque sensors are very costly. So rather than using a torque sensors, which will be like a minimum 5 times the cost of current sensor. If you have current sensor evaluation board you buy, right, then you'll get in 2,500 rupees. That's all. But torque will be minimum this 5 to 10 times higher than this. That is the worst case scenario, like the best scenario, not worst case, the lowest cost scenario I'm telling, which might not be that efficient. So you will get, so torque, as we know, torque is proportional to the current in our vehicles. So I'll take, instead of torque, I'll use reference current, because by controlling torque, if my flux is constant and I control my torque current, my torque will be controlled. Why I want to keep my flux constant? Because if most of our machines are designed to operate at knee point of magnetization curve. If I go above the knee point of magnetization curve, saturation will take place. If I go below the knee point of magnetization curve, underutilization of machine will be there. So that's why I have kept my flux at the knee point, and reference current will come into picture. So I'll compare reference current with the actual current. Only way to change the current is by changing the voltage. So this will change, okay, apply this much voltage so that the current, actual current matches the reference value. If that happens, then desired torque will be developed. If desired torque is developed, then actual speed will match the reference speed. So our control system will look perfect. Only problem is reference voltage is analog quantity. Power electronic converter need digital signals to 1, 0, 1 being on and 0 being off. So I'll convert this with the help of analog to digital signal conversion takes place with the PWM signal. That is pulse width modulation. The amount of time for which a particular switch should be on or off will be decided by this PWM, corresponding to the reference voltage. So to control induction motor drives, we have V by F control, which is coupled control. To say what I mean by coupled control is that if I change the stator voltage, if we recall the equivalent circuit of induction motor, simplified equivalent circuit of induction motor, if I change the stator voltage, my flux is going to change and my torque producing component is going to change as well. So that is a coupled controls. So this is all change in the current in your magnetizing current is always going to be slow, and this will result in sluggish transient response. So we have field oriented control or vector control. Yes,
does servo motors can be used in the electric vehicles?
Okay, sir. I will just absolutely, servo motors can be used. Just to not have confusion, I will just tell you what is my understanding of servo motor. According to me, any motor can be a servo motor. It can induction motor can be servo motor, or a PM motor can be servo motor. Only thing is the percentage dynamic accuracy should be below 0.01% second. Then it becomes a servo motor. So definitely any motor can be used. So servo motor can also be used for this application.
Okay. Okay, sir. Thank you.
Thank you, sir. So we can go with field oriented control. So field oriented control we'll be discussing in my talk. So it's a decoupled control, and torque and flux are going to be controlled indirectly. That means if you want to control flux, only flux changes. If you want to control torque, only torque changes. They are not interrelated. It gives fast transient response and excellent steady state response. There are no torque ripples. With a direct torque control also, it is a type of a scalar control, but instead of like field oriented control does not take into account harmonics or saturation. So this says no, we'll control torque and flux directly. It has fast transient response. Which among the two is better? To be frank, I don't know, because people are a bit, this opinion is highly divided. Some people believe direct torque control is better. Some people believe field oriented control is better. I prefer field oriented control, and my concentration is more on this. In direct torque control, only thing is there is a hysteresis current controller loop, and like hysteresis loops are there for torque as well as flux. And when we talk about hysteresis, there's going to be hysteresis band, and there's going to be a little bit chattering. Right? So ripples are going to be high. Torque ripples will be there. Undoubtedly, there are torque minimization schemes are there. There is something called space vector direct torque control. But again, once you bring into that, is it direct torque control or not? That is a question. So we'll come to vector control. This is developed in 1970s and commercialized by 1980s. And how is the latest technique? Because we are yet to come up with the better techniques than vector control, and there are huge scope in vector control. I'll be discussing those areas which we can point in vector control for development. Direct torque control, only problem is it suffers from high torque ripple. Still research is going on in the area of vector control. So just to give you the basics about vector control, this is a paradox. We first shifted from DC motor to AC motor because we said DC motor are less efficient as compared to AC motors. But if you look at the speed torque characteristics of DC motor, it's the best. Separately excited DC motor. Torque is proportional to phi IA. You play with the armature voltage, IA changes, torque changes. You play with the field voltage, flux changes, torque changes. So change in armature voltage affects armature current only and results in change in developed torque. Change in field voltage affects field current and field flux and only results in change in developed torque. So this is a perfectly decoupled system that we are having. So we wanted the same system to be replicated for induction motor. So induction motor also we want induction motor to behave as a separately excited DC motor with the fast acting power electronic switches to implement the vector control and the fast acting DSP processor which can implement a control algorithm. This is achievable. So in VFIF, what was the problem? We were controlling the magnitude of current and voltage or voltage. Hence it was called scalar control. It cannot provide decoupled control because of which there was a sluggish response. Previously, more VBIF control was being concentrated because the vector control required sine and cosine manipulations, computations, and processors were not good enough for that. Now we have this. Just to give an example, once I was working with one of my student. It was not for this vector control, but it was for grid tied inverters. So there he wrote a code. In my code, he changed sine theta, just he wrote. And my code took execution time of milliseconds. I wanted my code to be executed in 10 microseconds. And I was very confused. Some 200 lines of codes were there and we were searching out, spent a couple of days on that. Then I found out that he has used this. We wanted to use IQ math library for cosine and sine, which did this. So that is the impact of using sine and cosine. So vector control, in simplest term, it controls the phase, frequency, and magnitude. We have three things: Im sine omega t plus minus phi. So vector control is going to control your Im, your frequency omega, and your phase angle. So it's going to control phase, frequency, and amplitude of stator current in induction motor so that the desired speed characteristics can be obtained. Heart of vector control is ABC to DQ transformation. This is what is meant by ABC to DQ transformation. Let's think of it as a simple mathematical block. When I was doing my MTech and we had that modeling of electrical machines, I was really scared of this topic. I could never comprehend with this set of equations and modeling. But now I think of it as a simple block. These are VA, VB, VC. It can be IA, IB, IC, current, voltage, or flux, any three-phase sinusoidal balance quantity. So these three are AC quantities, and I get VD and VQ as output. These are DC quantities. So I converted my ABC three-phase AC quantities into two DC quantities. If I talk about current, then I had to control three currents: IA, IB, IC. These currents I had to control phase, frequency, and magnitude. So 3 cross 3, 9 quantities has to be controlled. If I talk about this transform, now I got ID and IQ. They are DC quantities, so there is no frequencies, no phase angle, only magnitude. So instead of 9 quantities, I am controlling only 2 quantities. I have noted the equations below. This is for VD, this is for VQ. Another input is theta. This is the rotor position. The same theory is applied for your shunt active filters or any grid tied inverter or solar or wind. We call it SRF theory, synchronous reference frame theory. That is also applicable there. So in this, what we will resolve the three-phase currents, IA, IB, IC, into two-phase DC quantities, ID and IQ. These are rotating quantities. So D axis is a flux producing component of current, and Q axis is a torque producing component of current. So I will tell you my interview question once I appeared for one PhD interview. And the question was this was about this only. So they were talking about I alpha and I beta is a stationary reference frame, and ID and IQ is the rotating reference frame. Then how it is if rotating reference frame? Then why we are using this? Why it is constant? The analogy that I used is like a merry-go-round. A merry-go-round is rotating. Your friend is standing on the merry-go-round, and you are standing at one position. So your friend will come near to you and go away from you. Again, come near to you. This is your AC. Now you start running with your friend at the same speed around the merry-go-round, and both of you are stationary with respect to each other. That is your alpha beta frame. You are stationary with respect to each other. Now you jump. You decide to jump over the merry-go-round. You are rotating, and your friend is also moving with the merry-go-round. But with respect to each other, you are stationary. That is your rotating reference frame. So in this vector control, we use ABC to DQ transformation to transfer three-phase AC currents into DC DQ quantities. D axis current is flux producing component of current. Q axis current is your torque producing component of current. To control flux, you will control D axis current. To control torque, you will control Q axis current. So D axis current is analogous to field current of a separately excited DC motor. Q axis current is analogous to the armature current of a separately excited DC motor. So D axis current is at 90 degree to the Q axis rotor current. It has to be maintained for vector control. Change in D axis does not affect the Q axis and vice versa. Right? For D axis represents flux, so we will keep it constant. The torque developed by the induction motor is proportional to Q axis, right? So torque is proportional to ID into IQ. ID is your flux producing component of current, and IQ is the torque producing component of current. If I keep my ID constant, that means my flux constant, then torque is proportional to IQ only. So I can control my IQ current and control the torque. So this is my vector control of induction motor. I use PSIM to simulate this. So this is let's assume this is a DC supply or battery. This is your inverter, 6-switch inverter. These are the 3 upper switches, 3 lower switches, and these are the 3 legs. I have connected this to induction motor here. This is my load, and you have this speed sensor to measure the speed. You have 3 current sensors to measure the current. So this is your power circuit. Okay. Now let's have a look at the control circuit. So when you're implementing this on a DSP, the first thing you will do is configure your ADC. So your ADC, you have to give at the ADC appropriate channels. You have to give the inputs. So my input will be this current 1, 2, 3. So I give 3 currents. I will need to, because your noise will be picked up by our wires and our sensors. So I'll just have a filter, low pass filter, having very high cutoff frequency, let's say 5000 Hertz. Next, if you are using your encoder, incremental encoder with indexing pulse, you will use this and give it to the QEP circuit, quadrature encoded pulse circuit in your DSP processor. So these are our inputs done. We'll configure our PWM circuit by stating whether it is up-down counter, what is the frequency, what is the period, what is the peak value. So once this initialization is done, we can implement an algorithm. So we'll have the 3 currents sensed by ADC. We'll process them to low pass filter to remove the high frequency noise. Then we'll perform ABC to DQ transformation. So these are the 3 inputs plus this input theta. How we obtain this, that I'll let you know. QEP circuit plays a role. That is quadrature encoder pulse circuit plays a role here. I got my ID and IQ currents. These are the actual ID and IQ currents. There are 2 loops, outer speed loop. This is my speed loop. It processes the speed error. And 2 current loops, inner current loops, that is D axis current loop and Q axis current loop. So this is my D axis current loop. This is my Q axis current loop. So this is the speed command. Speed command is provided by the speed command is provided to us by the driver. Once the driver speed command comes on one of your ADC pins, that will be sensed that okay, the ADC will scan all channels. Okay, this is the speed command. It will compare the actual speed obtained from the QEP circuit here. This is the actual speed. The output of this is a speed error, which is processed by a PI controller. Now PI controller will say, okay, this is the speed error. Let's think of it first as a black box. This is the speed error. What should be the output of torque? What should be torque required so that this speed error can be reduced to 0? If I need to accelerate, my torque will be positive. If I need to decelerate, my torque will be negative. If I want to keep my speed constant, there will be no change in the value of the torque command compared to the previous value. As our torque is proportional to current, I get this IQ command value, that is desired value of IQ. So I get a reference value of IQ and I have actual value of IQ here. So I'll compare this reference value of IQ with the actual value of IQ. The resulting error is again fed to a PI controller. This PI controller will process the errors. So it will say, okay, if I IQ current, if you check modeling of induction machine, there is IQ current is there, there's IQ Q axis voltage is also there. So I have got my Q axis voltage. So if I increase this voltage, current will increase. If I reduce this voltage, current will reduce. If I keep this constant, current will be constant. So based on this logic, my PI will process how much voltage should be maintained so that the reference and actual values of the Q axis current are matching. So I got this DC value of Q axis voltage. Now coming to ID. See, ID is the flux producing component of current. If I want to keep ID constant, means my flux is constant. As our motors operate at the knee point of magnetization curve, I'll get my flux value. How I get my flux value? I will run my motor at no load. At no load, the current being consumed is ideally only for the flux production. So that no load current forms my magnetizing component of the current. So this is the magnetizing component of current that I got, that is held constant here. That is compared with the actual ID obtained here by ABC to DQ transformation. Resulting error is processed by a PI controller, similar fashion to the Q axis current loop, and I get VD value. This is the voltage, D axis voltage I need to maintain so that the error between the reference and actual value of D axis current is 0. So I get the outputs here. Now these two voltages are my DC quantities. Inverter needs digital signals. There are 6 switches, so I need 6 quantities. So I'll convert DQ to ABC, that is inverse transformation. Again, theta is the input here. So I get VA, VB, VC. So this VA, VB, VC has to be processed by a limiter. This limiter job is only thing that your VA does not exceed the peak value of your carrier signal here. This carrier signal you are set in the period registers in your DSP. So you got these 3 signals, they'll be compared. Now 3 signals are again analog signals, AC quantities, they have to be converted into digital quantities. So we'll compare them with the carrier. Sinusoidal pulse width modulation there, you can go with space vector modulation also. Previously, like when I did my PhD, I wrote a code for space vector modulation. I was not aware much about the new facility in DSP, but currently what are DSP processors are there? There is a provision. Only one register has to be set. Let's say a register A1. If you set it at 1, you set register at 1, A1 as 1, then space vector modulation will take place. If you set this register at 0, sinusoidal pulse width modulation will take place. Only thing you have to set the carrier and give them. You need not write a code. So what it will do, you have to just give these values, VA reference, VB reference, VC reference to the specific registers or specific variable. Once you have done that, it will take care of by itself. So I got my 3 voltages. 3 voltages I got. VA, VB, VC reference. I'll process by the PWM and I'll get 3 signals. Q1, Q2, Q1, Q3, Q5. So Q1, Q3, Q5 are digital signals. Hello, sir. Sorry, I'm not unable to hear you. Vinod, sir, I'm sorry, but I'm unable to hear you. There is a lot of disturbance. So I got these 3 signals, but I have 6 switches. So what I'll do, I'll connect a NOT gate here, because when upper switch is on or lower switch is off, upper switch is on, lower switch is off, lower switch is on, upper switch is off. That's why NOT gate plays a role. Undoubtedly in simulation it will work. In DSP you have to, there is something called dead time. That means when this turns off, about 4 microseconds or lower time has to elapse before this can be turned off, because turning on and turning off also takes finite amount of time. So dead time registers have been set in DSP so that this shoot through fault does not occur. Now coming to theta, how you got this theta? So we got the speed here. So I convert the mechanical speed into electrical speed. This is my rotor speed. So I have to add my rotor speeds plus slip speed will give me the rotor speed plus slip speed will give me the synchronous speed, because I'm going to control the stator currents. So that's why I need the stator currents need to be operated at synchronous frequency or position of stator flux. So I got this rotor speed. I need slip speed. How do I find out slip speed? By this formula, right? 1 by TR, that is rotor time constant, into ISQ upon ISD. These are the reference values. If you have these values, you can add with the rotor speed and get your synchronous speed. Integral of synchronous speed will give you theta. That is the position of the stator flux. Looking at this diagram, what all things new we can explore and do? One is this PWM. See, PWM is always going to make the system slow. So what we can target is in this PWM, what our next target can be, uh, how to make it faster, how to make a switching table, like just like a DTC, direct talk control, how to make the hybrid of that, how to remove this PWM and bring in this switching table. You can use ALN, you can use ML, machine learning for that. Other thing is PWM in this. EMI interference will play a role. There is something called random switch PWM, random PWM. That means your switching frequency is not fixed, it is random. Uh, in this, if your this estimation is wrong, your actual speed is wrong, and entire algorithm fails. And if you talk about rotor time constant, rotor parameters are not directly measurable, and you'll measure them and put them. But because of aging, because of heat, right? In electric vehicles, motor is going to be heated up so fast. So this rotor time constant will change. So you can have fuzzy or ANN or machine learning to detect the rotor time constant without actually measuring it. So that is another aspect that you can think of. Can we play with these switches? Can we chain the switches? Let's say we have silicon carbide switches or some other switches which are more costly, and lower switches we are not switching that fast. Can we plug and play and reduce the switching losses and increase the efficiency? Then one topic will always be, there is this PI. PI has two constants, KP and KI. Either you can tune them with the Bode plot considering some assumptions, but when we talk about electric vehicle, we may encounter n number of conditions which is not, okay for us to consider every one of them. So can we go with online tuning of PI controller? Can we go with online tuning using some simple equations, or do we need ANN and machine learning? But again, those, if you employ online, it will be again a challenge. Do we have a separate processor, or we have some cloud computing that whatever data you're driving data is going to a cloud, the cloud is computing what should be value of KP and KI and giving back to you. That can play a role. You can go with sliding mode controller. Now I give a scenario. You are driving an electric vehicle on a road and this current sensor fails, or sorry, this speed sensor fails, or one of the current sensors fails. What will happen? You're driving at a speed on a highway, let's say at 80 km per hour, and your speed sensor has failed. What will happen? Can you think about it? An accident will occur. If you're lucky, the you'll get a signal speed sensor failure, please stop at the side. How can we correct this problem? Anyone has any suggestion for this? How can we correct the problem? Okay, I'll give two examples. One is from a video on YouTube, and other is my personal experience. As a child, when I go home and I find my grandparents are very serious, and means I already broken a vase at home, and evening I come back and my parents are back home and my grandparents are serious, means no, I will get a beating or thrashing because I've broken it. Right? So by seeing their face, I can estimate what my parents are going to do. If I come home, my grandparents are okay, means I think the situation is normal, my parents will scold a little bit. This is without getting beating or without getting scolding, I'm able to estimate. Same way in rockets, when you're sending the oxygen fuel, it has very high temperature. You don't have sensors to measure that in kelvins. So you will measure some other temperature and predict what is there. So that is sensorless. Without having any sensors, you're estimating. Same thing, you should have provision for sensorless speed estimation. Right from Kalman filter to ANN to Adeline to the newly developed second order generalized integrators, you can use them. If you check research papers, second order generalized integrators, I believe every couple of months new SOGI is being developed. You can use that, or new PLL is being developed. You can use that. Kalman filters, same thing goes with Kalman filters. There is a square root Kalman filter, sparse Kalman filter, extended Kalman filter, and other variations. You can explore them for sensorless speed estimation. There are other observer techniques like sliding mode observer. Again, sliding mode observer, again, we get that back EMF which needs to be filtered with a low pass filter. In this, you can put your add-line or you can put your SOGI or MSOGI in this and try to improve that. So research possibilities are limitless when you talk about sensorless control. Other thing less explored is current sensor. If one current sensor fails, what will happen? Either you can observer-based system, or in second case, fault tolerant system. That means even if one thing fails, how to go next with the, how to still keep it working. Your electric vehicle may not work as it normally works, but at least it will take you to nearby garage or nearby destination where you can get the repairs done. That is called fault tolerant operation. If one sensor goes out, okay, IA plus IB plus IC is equal to 0, these two will work. But you will get a signal one sensor has failed, you go. If speed sensor fails, you get a signal speed sensor failure, it will run on sensorless speed estimation. Similar things have to be there. Any point of discussion in this slide? In terms of research, I've talked about the estimation of this 1 by TR. I've talked about the sensorless speed estimation. I've talked about fault tolerant operation. I have talked about how to implement this with a switching table using AI and ML, and how to go for random PWM techniques or some other PWM technique you can develop. Anything any of the participant would like to suggest or a research they will like to think about. And again, I said about the switches as well. Just to have, a little bit of discussion. So it's not only me speaking all the time. One thing I forgot to include in this was this ID command. If you keep it constant, you can go to the base speed only. If you want to go above base speed, that is field weakening region, this ID needs to be changed. Once this ID, so you need to have algorithm. If I want to go above base speed, what should be value of ID? We call it maximum torque per ampere control. So if ID changes, then ID square plus IQ square, whole root of that is your stator current magnitude. So IQ also needs to be changed. Some algorithm has to be there to change this. So field weakening is the option. So mechanical gears we have talked about. We can go with electrical gears with field weakening. So this is a speed. I'll just reduce the mechanical time constant to very small value to fit in this. 1000 is the base speed and I'm reaching there. So this small overshoot is there and it takes time to settle. So you can use your controllers to rectify this. The speed reaches the reference value at about 1.15 second. And see the current here at after 0.15 second, current is low. Before that, current is at the rated value of 45. Just like your starter, initially in acceleration, high power is required. So it will force the current to be at higher value so that we can maximum possible permissible value. So we can get faster acceleration. So starter is not required. And that's why with the use of vector control, this drives soft starting of induction motor, which was using 3-phase AC voltage controller, that does not have great market left now. Currents are also sinusoidal, so there is no problem of harmonics. So next point I'll cover in short is electrical differential. See, these days we are having hub motors. Motors are fitted inside the wheel. So in normal, your internal combustion engine, the mechanical differential divides the force being applied at both the vehicles, left side vehicle wheel and right side wheel, not vehicle wheel, so that we can take a turn. Suppose I have to take a left turn, then the left wheel has to be slow, right wheel has to be fast. I'll take a left turn. So the control of speed of two wheels on the opposite side of electric vehicle to facilitate the turning of vehicle around the curvature electrically is called electric differential. See, this vehicle is there, you have a motor, you have fixed gears, and this is the mechanical differential, right? You can have two different motors, two hub motors controlling two separate wheels, right? With fixed gears, this is not hub motor, two motors controlling two different wheels. You can have hub motor controlling two wheels. So this gives you provision. If you're like this structure, like this or like this, then you are free to control the speed of the two wheels to get the vehicle motion around the curvature, take left or right turn. So mechanical differential is not required. So what is problem in using two motors? When you use two motors, you have two inverters. Two inverters means 12 switches, and switches will require gate drivers. Just to give you example, 1200 volt, 150 ampere dual pack IGBT will cost about 2,500 to 3,500 rupees. But if you want to buy a gate driver for this IGBT leg, it will be 6,500 to 7,000 rupees. That's why gate driver cost we want to work on. And undoubtedly, more components means more cost, more reliability issue, more complexity will be there. So the thing is, can we have one motor to control both the wheels? I'm repeating. Can one motor control the wheels, two wheels? It can, but then the motor will drive at the same speed. Can we have two set of rotors to control the two different wheels separately? So this has been my work, dual rotor PMSM. That means there are two rotors, inner rotor and outer rotor. Each rotor has to be controlled at different speed. So I have worked on something called dual rotor vector control. This is what I'm placed. I will just show you the waveforms. So this is a drive cycle, right? Drive cycle means whenever you test a vehicle, you need to test on a drive cycle. You're like new European driving cycle, urban driving cycle, then your American driving cycle, your Japanese driving cycle. So these driving cycles test acceleration, deceleration, constant running at constant speed, and these things, braking, all these parameters. So you'll see this is the vehicle speed. So whenever torque is high, acceleration is there, torque is high, acceleration, deceleration is there, torque is negative. In between, there is a constant torque. So with some techniques which I had used earlier, the two wheels, the blue is the speed of the rear left wheel, pink is the speed of the right wheel, and red is the average speed. So vehicle average speed was remaining constant, but the two wheels are having separate speed. In that case, the motion will be highly erratic, and it can cause some accident. So the vector control of dual rotor, what I worked on, see here a small change in speed is there. This is for rear right wheel and this rear left wheel. See, these two speeds are different. So this is a differential speed. Different between zero means that speeds are equal. Here the left wheel negative means left wheel has higher speed. So see here the motion. Displacement is like this. The vehicle is not running at straight line, but at different points. It is taking turns. So the current required during this acceleration period is very high, deceleration period is low. Same is the case with the torque. Because of torque only current is going to be high. That's why we need to bring in super capacitors here. And the battery charging plays a role. When the motor is not moving, the battery charge is constant. When there's acceleration, there's a steep fall in SOC of the battery. When it is running at constant speed, still the battery is providing power, but the SOC's fall is very steep. With this technology, the distance traveled, we checked for about 275 meters. And we checked it for this driving cycles, three different driving cycles we have checked for. And they're running fine. And this is the graph of for two different driving cycles, speed versus torque, and this color indicates efficiency. So you can see this blue and red and green are lower efficiency parts, and this red and maroon are the higher efficiency part. So one of the topic of research can be how can we control the speed of electric vehicle, or how can we control the propulsion motor in electric vehicle to ensure that it is operating near the maximum efficiency. If we do that, the amount of charge required or amount of battery that will use a battery power will be less. We'll be able to cover more distance over the full charging of the battery pack. So this is another area that we can explore. So new area that is coming up, you have a rectifier, DC-DC converter plus inverter. We can combine them with something called Z source inverter. Right? Professor F. Peng has reported this converter, and he has quite a few paper on this. So this is a converter which combines battery charger plus inverter into one. So this is the one thing that can be targeted, and you can explore this. Two of my PhD students are working on the Z source inverter for EV applications and for battery charging as well as for the propulsion of motor. So I'll just give you the difference between the two. One is a structure developed. They call it Z, or impedance network is connected between the battery and the inverter. And this is the PWM. In normal inverter, you have this carrier and you have VA, VB star, VC star reference. Whenever reference is greater than carrier, output is high. Let's say this SAP, SBP, SCP are the upper switches for phase A, B, C. SAN, SB, and SCN are the lower switches for phase A, B, C. So for upper switch, whenever the reference, let's say A, is higher than the reference, in this region it is higher than the reference, so it is high. Switch is on. When upper switch is on, lower switch is off. When A phase is VA star is lower than the carrier, this is low. Right? The switch is low. When the switch is low means it's off, the lower switch is high. That means it's on. But between this turning on of SAP and on this line turning off of SAP and turning on of SAN, some dead time has to be there. Otherwise, there will be shoot through fault because the switch require finite amount of turning off time. So dead time means will blank. Both the switches will be not given any gate pulse. Vandan bhai. So in this is for Z source inverter. You check this. This gray areas are there. So what we want to do, we want to actually cause a shoot through problem. We want to have shoot through. This gray area is shoot through. That means the upper switch is also on, lower switch is also on. Why we are doing this is same as the boost converter. Whenever shoot through is occurring, that means the boost switch is on, energy is being stored in the inductor. When we open the switch, the DC voltages, the battery voltage plus the voltage across the inductor. That is how we are charging the capacitors there. So Z source can be another parameter. So usually in our inverter, the output value of the voltage is M into VDC by 2, M being the modulation index, V in by 2 or VDC by 2. Here B comes into picture. B is the boost factor. The boost factor means 1 upon 1 minus 2D. D is the shoot through duty ratio. For how much time your duty ratio is going to cause shoot through. That means all switches are going to be short circuited. Means the legs are going to be short circuited. That is 1 upon 1 minus 2D. Where T is the total time, T0 is your shoot through time. So D is 0.5 means it will be too high. It will be 0, right? D is 0.5 means 2 into 0.5 is 1, 1 minus 1, 0, right? D is 1 means that will be negative. So you cannot go above 0.5. That's the main thing in this. So by controlling the shoot through period, you can control the value of DC voltage. So DC-DC converter goes out of the picture. So I will just go to some other part. Yeah. So whenever we'll talk about EV, the charging of EV will play a significant role. Charging of EV, yes sir, I'll be completing by 11:30 sharp. Whenever there's interaction between EV and grid has to take place. So there are two parameters, vehicle to grid and grid to vehicle. Vehicle to grid means we'll utilize the energy stored in the EV batteries to contribute with the electricity back to the electric power grid as and when the electricity, the utility company requests for it. That means your battery is charged, you plug it into the socket and it will provide energy to the grid, right? So your vehicle is acting as a source, and grid to vehicle means you are charging the EV batteries. So just think about microgrid. This is standalone microgrid, means there is no connection with the grid. So your solar PV, your battery connected to a DC link to DC-DC converter. Solar PV can feed the load. It can feed the battery. Battery can feed the load. Battery can get charged. And this is your AC because our loads are AC. You can connect a diesel generator to maintain the continuous supply, but diesel generator means again carbon footprint reduction is going out of picture. You replace it with the grid now. So grid is always available. We are saying here, utility, the reliability is higher here. So we are going for solar energy because it is abundantly available across 10 months in a year. So this is a case scenario study, and I'll complete in 5 minutes. So let's assume a case you are driving to college at 9. College timings are 9 a.m. to 5 p.m. and you arrive at 8:45. You park your electric vehicle in the parking lot of college and you leave at 5:15. So what is your electrical vehicle doing from 8:45 to 5:15? It is remaining idle, right? So can we make of this use of this idle electric vehicle from 8:45 to 5:15? Can the vehicle make some money for the faculty? Can the electric vehicle contribute to the betterment of society? Can the electric vehicle help avoid power cuts? The answer is yes, right? By this, your battery is your electric vehicle battery. You are connected to grid through bidirectional DC-DC converter. Undoubtedly, there has to be bidirectional port in your parking lot. That the roof of the parking lot, you can have solar PV. Right? So this battery can provide supply to the grid when the tariff is such that high. When the tariff is low, it can get charged. But what is the minimum charge? You have to decide. Other thing, if you are centralized system, the battery maintenance cost is there. You have to have DC-DC converters are there, large DC-DC converter. Here, decentralized system. And if one battery fails, one bidirectional DC-DC converter fails, there is not a problem. So this is your V2G, vehicle to grid. So your decentralized batteries in this. This can help you form a microgrid. It allows your incorporation of solar panel. It has economic benefits for the EV user. It has a provision for power trading. This has led to V2G, right? This is your electric vehicle. You need not buy a new bidirectional DC-DC converter. Already it is there in your electric vehicle. You can use that. Only thing you require is synchronous buck rectifier or dual active bridge DC-DC converter. So dual active bridge DC-DC converter is the most promising DC-DC converter which you can explore, right? There's a lot of scope in the design of this converter as well as the control of this. So key points for V2G will be integration of electric vehicle with the power grid. V2G provides electric vehicle owner charging at low load period. That's what I said. When the tariff is low, you can charge at low electricity price. You can supply to the grid. When the power prices are high, you can make money with this. And this requires connection to grid, and undoubtedly smart metering has to be there. Some communication has to be there. Right. So requirements are charging structure and location. You need to have a charging port, bidirectional. There should be provision for bidirectional energy power flow. There should be controller for this, control algorithm for this, communication between between your vehicle and the grid, some intelligent metering, and solar. If you include solar in this, again you're helping the grid as well as reducing carbon footprint. So what is the impact and application? You can charge your battery by drawing power at night time or low tariff period and discharge it at the daytime. Even if power cut is there, you can use it. The impact will be reduced electricity bill and reduction in CO2. So I think I'll stop here. This is a slide. Research topics we can discuss about is what is role of AN and AML in electric vehicles and what are new developments are there. Thank you. If you have any queries, suggestions, or discussions, we can have it right now, or feel free to email me as well. I'll be happy to have a discussion with you in this regard. Thank you for the patient listening. Thank you. Over to you, sir.
Hello, thank you, sir.
Thank you, sir.
Any participant has any query? Session is on open to Q&A, है ना? Is there any query?
Sir, solar energy can be used for charging the battery of electric vehicles.
Yes, it can be used. Like I said, we are trying to incorporate that more and more use of solar energy in charging electric vehicle. Like the paint of your car can be a PV panel. Like PV paints are there. The glass in your car can be a PV panel. There was a electric vehicle that made with a roof of the electric vehicle being mounted by panels. Only thing is our panel efficiency needs to go high because currently the rate at which it will charge is different. But suppose you are parking your vehicle in a parking lot. More often than not, the parking lot rooftop does not have anything. It's just a rooftop. We can place our PV panels there. So because larger number of PV panels means larger power will be generated. That can be used to charge your battery pack. At your home, you can have rooftop PV which will charge a battery at your home. And when you drive your electric vehicle back to your home, that battery can be used to charge off your electric vehicle even at night. That can be the provision.
Okay. So electric vehicles are now running in India. Means, are there any companies which are manufacturing in India?
Yes, sir. There are quite a few companies manufacturing electric vehicles in India. I'm not if there's a Bangalore-based firm, Areva, that is there. It has started to ads are also coming these days. In Gandhinagar itself, we have a couple of companies that are manufacturing electric vehicles. Mainly two-wheeler vehicles are there.
Two-wheeler vehicles.
Tata Motors, Hero Motors, all they are working on electric vehicles.
Working.
Hero bikes are there.
Hero bikes and Oreva bikes are there.
Yes.
But
and a lot of startups are coming up. RTEM is also there. There is a company called RTEM which is manufacturing two-wheeler bikes as well.
Okay. Thank you, sir.
Thank you, sir.
How to reduce the charging time? What type of technologies are used to reduce charging time?
Sir, one way of reducing charging time is we need to go with DC charging. That means you already have a DC-DC converter with you and your DC battery which is already charged, and then with that you charge the battery. But still faster time will be swapping of the battery pack. That is the fastest you can have.
Thank you.
I think, Dr. San, this is all.
Thank you, sir.
I, Dr. Nagan Kumar, Associate Professor from Electrical Engineering Department of GL Bajaj. I would like to thank Dr. San for his informative and knowledgeable lecture on electrical vehicle. I'm sure that every one of us will be benefited from the knowledge or content shared by the speaker on electrical vehicle. With this, I once again thank you, Dr. San, for honoring us with your presence. Thank you, sir.
Thank you, sir. Just one line to add: this session will be beneficial to me as well as to quite a few of you. If we
Yes,
can have a discussion sometime, working on this, we can collaborate and try to take this further so that electric vehicles are more and more feasible. That will be, that's the main thing that I have to say. Thank you.
thank you. Thank you, sir. We'll try to approach you as soon as we get something on electrical vehicle, sir. Thank you.
Thank you, sir.
In continuation, participant will meet after 15 minutes. Till then, you can fill up the feedback form. Thank you all.
Hello, hello, hello.
नहीं तो लेकिन मेरे सोलिंग का मैं शेड्यूल में कुछ काम ना वो बोल रहा हूँ सोलिंग में कंपनी सोलिंग में अपने को कैसा अपनी देखो करने के लिए तो
Good morning to all participants and our esteemed speakers. Today we have with us Dr. Gaurav Dwivedi. So I would like to introduce about Sir Dr. Gaurav Dwivedi. So Sir has completed his BTech in Mechanical Engineering from IKG PTU Jalandhar, and MTech in Energy Systems from IIT Roorkee, and PhD in field of renewable energy biofuel from IIT Roorkee, India. He has 8 years of teaching experience in the field of mechanical and energy engineering and taught various subjects like IC engine, thermodynamics, fluid machinery, bioenergy, and others at various institutes like VIT University Vellore and Amity University Noida. Currently, he is working as assistant professor in the Energy Center at Maulana Azad National Institute of Technology, Bhopal. His area of interest is biodiesel production methodology, enhancement in fuel properties, and application of biofuel on engine operation. He has published more than 90 papers in various international journals and conferences. He got more than 50 papers in SCI and Scopus Index journal. He has published one book with international publisher. Along with that, he has contributed 5 book chapters. He got Young Scientist Award at NIT Trichy for his contribution in the field of renewable energy. He is an active member of Institution of Engineers India and Solar Energy Society of India and IEEE. He also served as guest editor for Material Today Proceedings and Journal of Traffic and Transportation. Recently, he also featured in Top 2% Scientists of the World from India by a survey conducted by Stanford University. I kindly invite you, sir, to enlighten us with your knowledge and expertise in the area of impact of India's energy and environment sector due to pandemic. Welcome, sir. Hello. Hello.
Hello.
Good morning to
Welcome,
all of
Gaurav.
you. Uh, Good, good morning to all
Just
of
hold on,
you.
Gaurav. Just hold on, Gaurav.
Uh,
ब्रजेश म्यूट कर दो बाकी लोगों को.
Sir, shall I start? Hello. Oh, oh, Is it visible?
Yes, yes, Gaurav.
Okay. Good
The at the
morning to
rate
all of
hash.
you. First, I'd like to thank coordinator Professor Dr. Mohit Bansal and the management of GL Bajaj Institute of Technology and Management, Greater Noida, Department of Electrical and Electronics Engineering, for organizing the such FDP related to energy engineering in the time of the pandemic. And it is very important for us to know the all the aspects of the energy. So today we are going to cover what is happening to our energy sector due to the lockdown, due to this pandemic, and we will slowly move step by step. First, we will understand what was the history of the energy and how we are also going to discuss the energy and environmental, how the energy sector, the conventional sector, is affecting the environment aspects of the earth, and what we are going to do about this with the help of this various program. So we are going to discuss all those. So before going to the content, first we will discuss briefly what is the why we are discussing the energy, why energy is very important for us. Because as we are one of the largest population of the world, we are going to be number one in coming years in the terms of the population, and the population density is also is on higher side in our country. So we have to take care of our energy need. So when we talk about the taking care of energy need, it means that every person, from poor person who is living in the village area, who is living in the hilly area, remote area, should get the assessment of the energy. He should be connected to the world. So for that, we have to build some scenario. What is our best possible scenario? That everyone should get the energy wherever he is living, whether he is living in the desert, whether he is living in the hilly terrain, or he is living in the sea coastal area. So that is our most priority. So for that, we are imagining some scenario. Scenario is an image of possible future condition, and we want our condition to be better or in best condition. But no scenario can be converted into reality. There may be some gaps in between that. So the gap or the achievement, like if you want to achieve 100% this energy allocation for the person, then when we are going to do it, there will be some losses. So we may achieve the target by 90%, 95%. So better we approach the target of 100%, that will be more beneficial for us. So we have to need to view in the future due to our population, due to our population density, and our cities like Delhi and Bombay, they are increasing daily. So that's why the cities like Noida, Greater Noida are coming into the picture due to the large population size. So the size of the cities are increasing. So what we have to do, we have to promote some specific policies. Like what do we mean by promoting the specific policy? It means that we are taking the one particular energy sector and searching and finding the solution. Like in the area of solar energy, we are working in the photovoltaic technology. We are also working in the solar thermal aspects. So we are also working on the appliance aspects. So that is the promotion of the specific policy. Then investment decision for the longer run. Which type of investment for in the energy sector is better for us? I will take the example of our the monthly saving. What we do in India, mostly people do LIC, and then take some are doing the mutual fund. So Why some people are doing LIC, some are doing mutual funds, some are doing FD? Because the safe, how safe is your money and how much you getting the return after some period of time, that will motivate you to invest in some plan. So similarly, in energy sector, we have to find some sources in which we are going to investment in a longer term. Like in large hydropower, it is not very feasible to investment in a large hydropower because there are various issues associated with them. So better we investment in the small hydropower or in solar sector or in the area of wind energy. So we have to explore the compatibility. So these are the some points which are related to particular scenario. Scenario is a complex issue, and for that we have to frame some rules, and then we have to estimate the population, and then we have to evaluate the starting condition. What is mean by rules? When we are developing an energy plan or energy policy, you will find that the Electricity Act will be there. There are environment policy is there. So we have to form some energy and environment policy for developing a particular sector. Then for we cannot develop a particular project for current number of people. That is the most important thing. If you are going to develop a particular project for the present population, then what will happen when the project will complete, the population will grow larger, and then again you will face the deficit of the energy supply in that particular area. So the project planning is very important, or it means that you have to estimate the population size in a very particular manner. Then what are the starting condition, how much you are investing, how much you are taking the finances. So that is the one aspect that you have to take care. Now this is about the possible future condition. Now we will go briefly into the energy history. We will not go deep into that, but for the a better understanding, we will go somewhat briefly into the what is the energy sector century back. In year 1990, 30% of world energy need was met by wood. In 1950, oil was the most potential source, and it became the 60% of northern part of America, that is the USA and Venezuela, become the leading producer of that particular source of oil. Then 1974 International Energy Agency was found, and natural gas comes into the picture also. In year 2000, nuclear became the prominent source of energy in the area of Europe and Japan. After that, in year 2018, China became the economic superpower because of the coal. Coal production and consumption was very high in the China in year 2018. Now, in year 1919, the population was 2 billion. In year 2018, it was 7 billion. So there was increase of 5 billion of population, but the consumption of energy was increased by 20 times. For year 2040, the prediction is that in the order that the prediction of the energy consumption or energy sources will be order like solar photovoltaic will be the number one source of energy. After that, gas will be there. Then there will be a coal. Then there will be a wind. Then there will be a hydro, and then there will be a nuclear. So this is about year 2040. So these are some history and brief about the energy sector. Now we will move towards our topic. What is the effect of the lockdown on energy sector and environment sector? We are going to discuss that. How the petrol and diesel demand were affected, and how the effect of the lockdown affect our air quality and water quality. So we are going to cover the energy aspects and environmental aspects. We will also see the future direction, what are the future direction, and what is the conclusion of this study. This study I have done, I have taken the data of last year and this current year of the lockdown till when the major parts of the India are in lockdown. So I have taken the data from the March to August and last year data also. I have compared the both the data, and the data is from the authentic government sources and some this government websites, and I have written a paper. This is under revision. So I'm showing this all the data and comparing the aspects, how we are facing the energy sector, how our energy sector behaves during this lockdown. So before going into that, there was there is a environmental aspects related to the energy. In the Paris Agreement is a historic milestone in international climate policy. The world's first comprehensive agreement on climate change, and 195 signatories were there. Entry into force in November 2016. Cover period post 2020. All the country obliged to take action, acknowledging differences between the countries, appropriate financial flows, new technology framework, and enhanced capacity building framework will support developing countries. So actually it is related to the environmental aspects, how to reduce the greenhouse gas emission, and then there are other parameters also. So the goals of this policy is related to that, like mitigation, limit global warming to well below 2 degrees centigrade, pursue efforts to limit to 1.5 degrees centigrade, achieve net zero emission in the second half of the century. And when you talk about the net zero emission, then it comes into the mind the use of the solar energy, wind energy, and the use of the electric vehicles. That comes into our mind. Adaptation, increase ability to adapt the adverse impact of climate change and foster climate resilience and low greenhouse gas emission and development. So that is the one aspect. And then financial aspect, that is very important. Work towards make financial flow consistent with low greenhouse gas emission and climate resilient development. So these are some policy issues related to our Paris climate change. Now, after that, there was a sustainable development goal were formed, and the sustainable development goal is applicable worldwide, and every country is working, mostly maximum countries are working towards the achievement of the sustainable development goal. As an energy engineer, as an engineer, whether we are from mechanical background or electrical background, you will find out that these goals are very much related to us. If you go through the point number 6, that is clean water and sanitation, then affordable and clean energy, that is totally dependent on the engineers only, how we are developing the technology, how we are going to address the issue. So that, and it is not about the developed country or developing country. There are large number of underdeveloped country in the area of the Africa and the other region. So they are in very poor state. So our target is that everyone in our country also, that everyone should get the clean water and sanitation. We have various programs related to like Swachh Bharat, and then affordable and clean energy. There is a Ujjwala Yojana related to this affordable and clean energy. There are various other policies related to the affordable and clean energy. So these are very important for us. So what point number 7 says affordable and clean energy? It says that by 2030, it ensures universal access to affordable, reliable, and modern energy services. Then by 2030, increases substantially the share of renewable energy in the global energy mix. By 2030, double the global rate of improvement in energy efficiency. Then by 2030, enhance international cooperation to facilitate access to clean energy research and technology. The example of this international cooperation was led by India only. As a country, as a larger country, as a country with larger number of population, what we have done, our government has initiated the Solar Alliance Mission. The Solar Alliance Mission includes the country which are very much interested in the area of solar energy. So they have various partnerships. They are forming the group and they are sharing the technology transfer. They are sharing the this data also. And they, with the help of the Solar Alliance, we are going to give boost to our solar energy sector. So that is the type of international cooperation. As a researcher, as an engineer, as a faculty member, you have heard various, you have heard about the agencies, DST, SERV. These agencies, when you apply for the project, you will find out that there are various projects which are of international collaboration. And when we talk about the international collaboration, there are various projects related to the clean energy and environment. So international cooperation, that fourth point which is covered, that is comes under the project also. That project, all the projects comes under this affordable and clean energy, that we are developing various type of prototype, patent and product for the society, so that the affordable and clean energy will available to everyone in society. Then cleaner fossil fuel technology. Our various researchers are also working on the cleaner fossil fuel technology and promote investment in the energy infrastructure and clean energy technology. So the purpose of this international cooperation to enhance the technology transfer and develop the energy sector. Then after that, by 2030, expand infrastructure and upgrade technology for supplying modern and sustainable energy services for all in developing countries, in particular, least developed countries, smaller island developing state and landlocked developing country, in accordance with respect to program of support. So not only there is a technology transfer, there is an upgrade in the infrastructure also. So various countries will support the infrastructure development that will enhance the energy cooperation in longer run. So that would fulfill our the sustainable development goal. Now, if we move towards our own country, India, we have set some INDC target. These targets are set by itself. India planned to reduce the emission intensity of its GDP by 33 to 35% by year 2030 from 2005 level. Then 40% cumulative electric power installed capacity from non-fossil fuel based energy source by 2030, a jump of 33% over non-fossil fuel capacity of 2015. Then to create an additional carbon sink of 2.5 to 3 billion ton of CO2 equivalent through additional forest and tree cover by 2030. Then USD 2.5 trillion, the creation of additional carbon sink. Additional carbon sink means we are going to plant more forest. So we are going to plant more trees so that this carbon sink will created. And for all these targets, we require large amount of investment or money to fulfill all these targets. So USD 2.5 trillion required for meeting India's climate change action between now and 2030. So these are the specific targets. Now, if we move towards our renewable energy goal, what we are going to do in the area of renewable energy, if you see, the solar and wind energy will increase, is already increased from 4060 megawatt and 23.76 gigawatt in 2015 to 100 gigawatt and 60 gigawatt by 2022. We are very much moving right in this direction. We are going to achieve this target in the solar and wind sector. Maybe we are going to complete before the scheduled date. In the area of biomass, the capacity to increase up to 10 gigawatt by 2022 from 4.4 gigawatt. Now, we are not going to promote the large hydropower due to the environment and ecological aspects of the large hydropower. They are affecting the environment and ecology of particular area. Sometimes what we have to do, the very large land area, forest area will be submerged when we build a large hydropower. Sometimes the entire city has to be submerged due to the development of larger dam. So government is avoiding this type of projects, and they are promoting the small and mini hydel projects. They are of very small capacity, less than 25 megawatt, and they do not affect the environment and ecology in a such a way as compared to large hydropower. This is very important energy source because in the hilly area, when there is no grid connectivity, we can develop a small mini hydropower project or a small hydropower project to fulfill the need of that particular area. So that is the one aspect of the energy that is very important for us. Other than that, in the area of nuclear energy, we are going to increase the capacity from 5780 megawatt to 63 gigawatt by year 2032. We are working in the efficiently in the area of nuclear sector also. The Kundakulam nuclear power project is already in operation phase, and we are producing large amount of energy from that power plant. And other than that, Jaitapur is in construction phase. So we are building large size nuclear power plant that will help us to meet the energy needs. Now, when we talk about the coal, we are one of the largest producer of the coal in the world. But the quality of the coal which we are extracting or producing is not very good. That can be used in our thermal power plant. So, or we can say that is not very efficient. The calorific value is on lower side. So what we have to do, and the emission aspect is also very poor of the particular type of coal. So what we can do is we are importing large amount of coal from the country like Indonesia, New Zealand. So we have to develop some clean coal technology. When we are going to develop the clean coal technology, the emission part will be very less with the help of this clean coal technology, and we are going to meet our target. So these are the targets in the area of renewable energy as well as conventional sources. Now, when we talk about the coronavirus, the novel coronavirus was first identified in Wuhan, Hubei province, China in December 2019. This is as per the report, and caused over 14.67 million cases and over 60.9 thousand deaths worldwide as of July 20th, 2020. I have not updated this data because we are covering the aspects of the lockdown. That's why I have restricted up to July and August, because after that the unlock starts. So there can be another study how the opening of the sector affecting the total energy scenario. Coronavirus has brought health and economic crisis to the mankind. It is one of the rare type of pandemic which happens after the 100 years. This pandemic also shows a positive impact on the energy and environment sector. Now, when we talk about the energy environment sector, it is showing some positive aspects. On 22nd March, the Prime Minister of India announced a 14-hour voluntary public curfew known as Janta Curfew, followed by a nationwide lockdown on 24th March 2020. And India, as per the July data, India was currently affected in the third place. Now, as per the today scenario, we are in much better condition. As the number of cases, we are in top 5, but our recovery rate is more than 95-96%. And due to the high recovery rate, we are overcoming this pandemic. And yesterday only, day before yesterday only, we got the 2 vaccine approval. So we are going to overcome this. In India, the sector like aviation, tourism, hospitality, retail, manufacturing, and automotive gets highly affected by COVID-19 pandemic. Now, this how the flow chart happens. The Janta curfew was on 22nd March 2020. After that, lockdown phase 1 was started 25th March to 14 April 2020. Then there was a lockdown phase 2, 15th April to 3rd of May. Then there was a lockdown phase 3, 4th May to 17th May. Then fifth phase of lockdown, 18th May to 31st May. Then unlock starts. The Unlock start them means the opening of the sectors start, and it was in slowly and progressively. And recently also some sectors are still closed, which are very vulnerable for our population, like the opening of children in the school. We have not allowed the opening of the school for all classes. So unlocking is going on right now also. Unlocking phase 1 June up to 30th June, then the unlocking phase 2 up to 31st July. But these are the major. In the unlock phase 1 and unlock phase 2 also, most sectors are closed, only few sectors are open. Now, if you go by sector, Janta curfew was on 22nd March, and in first lockdown phase, trading via e-commerce website and local vendor were opened to provide uninterrupted supply of essential goods such as grocery, medicine, and other food products. All other commercial services, industry production, and agriculture production were suspended. Public transportation was halted, including railway, flights, buses, etc. In second phase, agriculture, dairy, aquaculture, plantation, supply shops were relaxed and allowed to remain open. Small retail shops were allowed to open with 50% staff capacity. Interstate movement of a standard person was allowed. In third phase, regions were split in red, orange, and green zone according to their rate of spread and number of COVID cases. Normal movement was allowed in a green zone with some restriction. Orange zone was allowed by private vehicle only, and in red zone movement was restricted. After that, red zones were divided into contaminant and buffer zone, and authorities were given the rights to demarcate the same. After that, unlock phase 1, shopping malls, hotel, restaurant, religious spaces were permitted to reopen with some restrictions. We cannot say with some restriction, there should be lot of restrictions were there. The major focus was of economy boot up. In all the phase of lockdown, the economy was closed, and we are suffering, our economy was suffering due to this lockdown. So we started to unlock. Night curfew started from 9 p.m. to 5 a.m. Then unlock phase 2, in all area, most of the activities were allowed to operate, all the while imposing necessary health and travel restrictions. State boundaries are open, all education institutes remain closed. So this is about the methodology of how the lockdown and unlocking happens in the India. Now, what is happening to our energy sector? Due to lockdown, electricity demand was significantly affected. There was a decrease of 26% in the first week of lockdown, while the domestic demand increased. Automatically, when all the factories were closed, then there will be a decrease in the demand, because the industry sector consumed large amount of electricity. But in the domestic sector, the demand was increased because people start working from home. Renewable energy sources such as small hydropower, solar, wind, biomass stayed immune to the rapid decrease in the demand for energy generation. So renewable energy sector is not totally affected by this lockdown. They was as compared to the conventional sector. We are going to discuss that point also. The coal fields mining were reduced to 23% as compared to previous year due to the lockdown. Less demand for electricity led to the operation of thermal power plant at minimal capacity and low plant load factor. So the demand was less. So the operation of the thermal power plant, with thermal power plant, was well below their capacity. Now we will, in this study, we are going to address the sector by sector. First, we are going through the coal-based power plant. What is the happening to a coal-based power plant? Ministry of Coal, India estimates 319 billion ton of geographical reserves of coal in the country. So we are one of the largest producer, and proven reserves of coal is available in our country. India's coal import in March 2020 stood at 15.74 million ton, down by 27.5% compared to last year, due to the restriction imposed at various parts in the wake of coronavirus outbreak in the country. So it started from the March only, that after Sunday 22nd March, there was a decrease in the import of the coal. National Grid is owned and operated and maintained by state-owned Power Grid Corporation of India. Reached fully operation in July 2014. So it is the total how our electric supply is done in the all parts of the India, that is totally controlled by Power Grid Corporation of India. It is one of the largest operating synchronous grid in the world, with 371.054 gigawatt of installed power generation capacity as of 30th June 2020, out of which thermal power plants cover 2,30,599 megawatt, which is 62.3 of the total installed capacity in India. So this is about the grid. Now, the April-June period could be one of the worst quarter for the coal offtake in Coal India's history. You can see the percentage growth. After January, February, it was moving in positive direction. After that, it start to decrease. And from March, it is going in the negative. The growth is in negative phase till till up to June 20. So this is the data. This is the data of coal offtake, and the significant drop. This is this data. With the help of this graph, you can better understand the significant drop in the coal import volume due to the both demand and supply factor, offtake, consumption, logistic, and dispatches. So if you can see, there is a red line for the data of 2019 and the blue line for 2020. You can see the difference, how much there is a difference in the comparison of the coal offtake due to the demand and supply factors. So we are going into the negative growth. Now, if you go through this table, effect of thermal power plant, how are thermal power plant? Because thermal power plant are running on the coal, and due to this supply of the coal, they are affecting, and they are also affected due to the demand. So how they in normal days they are not able to meet the total demand, but in this due to the pandemic, you can see there is a growth is in negative digit, and it is not in the growth in negative digit, it is growth in a double digit in negative value. Now if you compare January 2019 to January 2020, that was a positive growth of 0.50. In February it is again 9.70 positive, and when they in whole month of the March up to 22 March, India was open. But you can see how it affect our economy. You can see only the last week, last 8 to 10 days we are under lockdown, but the growth is in negative. It is in minus 12.86. And when there is a total lockdown, the growth is in double digit of minus 29. Similarly, in the May, minus 21, and it is in June, minus 22. So we are totally and badly affected in the month of the April with the total generation in the case of thermal power plant due to the closing of the industry. There is a gradual decrease in the output power to 66 gigawatt in 2020 as compared to 94.6 gigawatt in 2019. After April, there is a rise towards normalcy. So March and especially the April, that was the month in which we are severely affected due to the lockdown. Due to COVID lockdown, the percentage growth in power generation in comparison to year 2019, it decreased to minus 29.43% in April, and after this in July it started to increase slowly. So after the month of affecting in the growth in the thermal power plant, like in January and February it is in positive, and after that March it is in negative, April it is very poor, minus 29.43. And after the April, when there was some economical activities were allowed and then some opening is there, it again started to grow towards the normalcy. and right now we are in that position only. Now, when we talk about that was about nuclear, the thermal power plant. Now, when we talk about the hydropower plant, how our hydropower plant behaves during the lockdown period. In terms of installed capacity, hydropower station capacity, India is now at 5th position globally, according to International Hydropower Association. As of 30th June, India's total installed capacity of hydropower station was 45,699.22 megawatt. Apart from this, small hydropower station has total installed capacity of 4,688.16 megawatt. The hydroelectric potential is estimated to be 1,48,701 megawatt. Out of the total hydropower potential, only 28.515 is in operation phase. 7.84 capacity is under construction phase, and 64.01 capacity is yet to be taken by under construction. So we can do marvelous growth in the area of the hydropower development, as still large number of the sites are not developed or under construction. The hydropower generation system was not affected by the lockdown much. They are not severely affected as compared to thermal power stations. Now, if you compare the generation of hydropower plant capacity all over the India, when we are going to compare the January 2019 to January 2020 data, the growth is in positive double digit. Similarly, for the month of the February, in the month of the March, the lockdown was in last week only, so the hydropower sector again was in the growth was in positive digit. It is not affected. But when there is a total lockdown starts, and in the month total month of April was under lockdown, that was in minus 8.59. And now the growth is in negative phase. When the starting opening of the sectors takes place, then in the month of the May and then June, it was again starting to growing rapidly. The generation capacity is again going to at the previous level before the lockdown era. So that was about the hydropower plant generation. In the start of the year 2020, there was increase of 17.63% from the previous year, but due to lockdown, it was decreases to minus 8.59 in the month of April. And after this month, it starts to increase very rapidly to 18.95. Now, when we are going to compare the hydro sector and the thermal power plant, you can see there is a decrease in the hydropower sector, but the negative growth is in single digit only. While in the case of the thermal power plant, the growth, the negative growth is in double digit. So you can clearly say that with the lockdown, the thermal power plants are more affected as compared to hydropower plant. On 5th April, in between the lockdown, on 5th April 2020, a pan-India light of events were take place. 9 p.m. 9 minutes was occurred with the initiative from the government of India. This event was a major test for great flexibility to respond to a sudden change in the load, because light will suddenly switch off for a particular period and then again switch on. So that is the one very big task, how to handle this sudden rise and fall in the load. A fall of 31,089 megawatt in demand was seen during the 9-minute event. In this event, the hydropower generation proved to be a key player in maintaining grid flexibility. The maximum ramp rate of minus 2728 megawatt per minute and positive plus 1977 megawatt per minute was provided by hydropower generator. So hydropower plays an important role in this particular event on particular date. Now, moving from the electricity or power generation sector, we are going to analyze our fuel sector, how our fuel sector behaves. The petrol and diesel supply. These are the conventional source with which we are running our vehicle. We are in developing phase of the electric vehicle. Electric vehicle is still in the nascent stage, and till now we have not very much regulated policy related to the electric vehicle. So our potential source of fuel for our transportation sector are petrol and diesel. And one issue which we are facing with the petrol and diesel, that's why we are moving towards the electric vehicle and alternate fuel, biofuel, that we are totally dependent on the other country. We are importing large amount of the petroleum products from the country like Iran, Saudi Arabia. So when there are two aspects related to it, which we, before going to the that phase of the lockdown in the petrol and diesel sector, you have to understand what is the problem we are facing in the this sector, in the petroleum sector in our country. First, we are importing large amount of crude oil from the other countries. So one, we have to pay in the dollars, where we are paying all the payment through dollars. So when we are expending our dollar, it affects our foreign exchange reserve. So that is the one aspect. We are putting large amount of money in the fuel sector for obtaining this conventional fuel. Then second aspect is that we are importing this oil from the Gulf country like Iran and Saudi Arabia, and when there is a problem in the particular sector, when there is a problem in particular sector, then problem in particular sector means when there is an issue in the area of the Gulf region, like if there is some war like situation, that affects our this fuel supply. Now the relation between the Iran and USA is affecting our fuel supply. When there is a tussle between Iran and USA said into India that you do not import any oil from the Iran. So that is the one aspect, that we are dependent on the other countries, and in coming future that may affect our self-reliance policy also. So that's why we have to find any alternative of fuel in our transportation sector, and the alternatives are use of electric vehicles, use of development of biofuel. So these are some major sources. So now when we discuss about the petrol and diesel supply, the forecasted non-renewable hydrocarbon resources in 15 sedimentary basin and deep water areas of India amount to a total of 28.1 billion ton. This oil and oil equivalent of gas. The growth in the country petroleum products demand in the second quarter of 2020 has been the lowest in the decade. Now, when all the vehicles, all the transportation sector, except the medical emergency vehicles and some necessary supply, food supply vehicles, were on the road, and except all the transportation sector is closed, so the demand is to be lowest. The lockdown has led to the around 15 to 20% of overall low demand rate. In April 2020, petrol sales went down by 64%, while diesel sales de-escalated by 61%. So that is the huge amount of the oil. So what government of India has done at that time? They purchased and built the stock of diesel and petrol supplies for longer period. They have increased the storage period from 15 days to 30 days. So they have done a good job in that particular area. They have revamped our storage capacity in the particular month. Now, effect of lockdown on this petroleum products, in various refineries, you can see in the month of the January 2019 to January 2020, the growth was in positive digit plus 2.7. In February, it is plus 1.33. And in March, it is in negative minus 3.97. And when there is a total lockdown, it is in minus 18.11. So the growth was in full negative double digit in the month of the April. India's fuel consumption, when there is in the consumption is also very less as compared in the, except the LPG. Now, all the peoples are at home, they are using the LPG. So for their foods, for meeting their food needs. So there is a growth in the LPG supply, which grew by 21% as nation was locked down, halted the transportation and economic sector. So except the LPG, all the sector reports the negative growth, especially in the month of the April. This is for all the petroleum products. When we take all the data, and you can see the minus 45.77 was the negative growth rate. Now, oil products import are also dropped by 6.5%, their first downturn in the last 16 months. So that is the very positive aspect because we are paying the money. So that was good for us. We are saving large amount of money in that particular period. The export of their refined product had their biggest rise year on year since October 2016 because of slowdown in domestic demand. The domestic demand, we are one of the largest refinery in the, we got the one of the largest refinery of petroleum products in the world. So the product which we obtained from the refinery were supplied to the other part of the world, and the demand was increased during the lockdown as the domestic supply was very less because many countries did not underwent the lockdown. So the demand is there. So we have supplied the large amount of this petroleum refined product to them. Now, total import and export of petroleum products. The import is in negative phase in the month of the April and May. In the month of the March, the lockdown is only last week, so it has affected our growth rate, but the growth rate is still in positive in the month of the March, while the export growth was increased in the month of the April. It is in double digit. That is the one unique aspect of this particular lockdown. Now, in the same period, from May to July, the rate of diesel and petrol in the international market have risen by 12% and 4% respectively as compared to the previous year. Now, we have gone briefly how the lockdown affects this energy sector. Energy is always related to the environment, which type of energy we are producing and how it is affecting the environment. In recent times, we are more focusing towards the renewable energy, renewable energy sector, and our growth in renewable energy sector is in double digit, while we are also increasing our conventional source. But in conventional sources, we are also working on the various type of technology which will help us to reduce the pollution aspect, because the pollution will become the one of the major source that will affect our survival on our earth. So on this planet only, we have a large amount of the pollution, not only in air pollution form. There is a water pollution, and we are also have a land pollution also, the supply of the plastic, and in the COVID time, the large amount of mask, sanitizer bottles, all these are various type of waste which have to dispose properly, especially the medical waste. There are chances of transmission. So that is the one huge aspect which we have to address. Now, what is the effect of the lockdown on environment sector? The environment sector got revived and rejuvenated up to greater extent due to the lockdown amid this global crisis. People are sitting at home, so animal can move freely. The emission due to several anthropogenic activities have dropped all over the globe. The northern and southern part of the India witnessed a reduction of 44% and 33% respectively in the air quality. Now, that is the one aspect that was very beneficial for us, how the air quality was affected. Air quality, actually the air quality is measured by the air quality index. It is one of the parameter which show the combination of all the gases, how all the gases are gases present in the air behaves. So with the help of the air quality index, we are going to decide our pollution level. Usually in the area of the Delhi NCR region, that is the air quality index. To maintain the air quality index at lower level is one of the challenging aspects. So we have to take care of that. Now the around 29 to 15% and 32% recovery in the air quality were observed in the eastern, center, western part of the country respectively. That was the one positive aspect. It become a blessing for our environment, that air quality improvement in the air quality. The reduction of the, not only in India, if you go at the world level also, there is a this decrease in the pollution level worldwide. So that is the one positive aspects of this COVID-19. Now it was reported that decrease in the transmission by 36 to 57%, corresponding to relative humidity of 67 to 85.5%, with the rise in average daily temperature of 1 degree centigrade. So these are the positive aspects of the lockdown on the environment sector. Now, what is air quality index? Air quality index is a measure the level of the air pollution, indicating the effect of air pollution on public health, how the public health behaves. Pollution, we have to categorize the air pollution in two categories. In every country have their own frames of laws to how we are going to segregate the pollution level. So we have categorized the pollutant in two categories. One is the regulated pollutant and one is unregulated pollutants. The regulated pollutants means which are governed by some law. Means these are very important pollutant component that is affecting our health and environment, and these are present in the large quantity, and we have to address these regulated pollutants. Unregulated pollutants are also polluted, but they are not in larger quantity as in current scenario. So they are not governed by some particular law. So that is the one aspect of that particular category segregation of the regulated and unregulated pollutant. Anyone is raising hand? If you have any question, we will discuss after the presentation. In between, you note down and we will discuss all those issues. So there is a segregation of the regulated and unregulated pollutants. So like in the pollutants which are available in air in our country, in our political geographical scenario, we have to categorize it as a regulated pollutants, while which are present in less quantity, we have segregated it as unregulated pollutants. So when you go for the pollution, when you go for the pollution center, the pollution components which we get on the slip, those pollutants are regulated pollutants. They have mentioned that these are the regulated pollutants, and these are classified like eight pollutants like PM10, PM2.5, particulate matter 10, particulate matter 2.5, 2.5 micron size, 10 micron size. These are very small, and NO2, CO, O3, SO2, NS3, and PB are considered for air quality index. All these components combine together and give one reading, and that is categorized as the air quality index. In comparison to 2019, an overall reduction of 43, 31, 10, and 18% in the concentration of the PM2.5, PM10, CO, and NO2 respectively has been observed in India due to the pandemic. So that is the one aspect, that the overall reduction is there. Then air pollution was noticed to play a role in COVID transmission. Now, coronavirus is transmitted through air as per some studies. So that's why there is a distance of some, there is a distance of between the people. The instruction was given there. So that air pollution played the important role. How the air pollution play important role, we are going to see. I have mentioned the references of the study, so you can go through the references. Higher mortality rate and rapid spread of virus was observed in the places having higher level of pollution. So when the pollution is more, the chances of transmission were more. Like in our countryside, in our village area, the air quality is always very good. So the chances of the transmission were less. So these are the variation of average concentration of PM 2.5 for the month of March to June of the year 2019-20 for Delhi, Kanpur and Mumbai. You can see. And what are the conclusion? That PM 2.5 matter less than or equal to 2.5 micron in size one of the major regulated pollutants. Kanpur witnessed an overall drop of 58% in the average concentration level. Compared to 2019, Mumbai witnessed a hike in the level of the pollutant in the May, followed by drop in the month of the June. Now you can see there were the largest number of the cases in the Maharashtra, especially in the area of the Mumbai. And when we go to the Mumbai, we can see in the particular area of Dharavi region, where the population density was on higher side and the pollution level was higher. So the number of cases were higher. We can correlate it. And the drop of 26%, 40%, 29% and 27% in the month of March, April, May and June respectively were observed in the Bhavana, which was considered as the most polluted area of the Delhi in year 2019. So in the area of the Bhavana region, there was a drop in the pollution level, especially in the area that particular PM 2.5. Now, Chennai witnessed an overall drop of about 57% in the average pollutant concentration. We have taken the data on the monthly basis, but we have summarized on the average basis. Now, this is the variation of PM10, how the PM10 behaves in various cities. Now, there was significant decrease in the concentration level of PM10 in Delhi during the lockdown. PM 2.5 also decreases, PM10 also decreases. That is very good for us. Compared to April 2019 and April 2020, witnessed a 48% drop in the average concentration of the pollutants. Now we are again back to the level of the 2019. If you go to the data of the January 2021, recently, we are again come back to the same phase after the opening of all the sectors. The pollutant level in Kolkata was considerably less than the pollutant level in 2019. So the study shows that in all the major cities, there is a drop in the pollution level. The weekly average concentration of PM10 in Mumbai dropped by 18, 17 and 38% in the March, April and June respectively in 2020 when compared to 2019. So PM10 also dropped down. Now this is the graph for variation in the Mumbai. Now third pollutant aspect is the CO, carbon monoxide emission. Vehicular emission and some industrial activity are the main contributor to carbon monoxide in the atmosphere. So when we close our transportation sector and industrial activity, we are going to see that there will be a drop in CO emission. Compared to 2019, the monthly average concentration of the pollutant was decreased by 54% in April 2020 in Delhi, and overall decrease of 45% was noticed. In 2020, Mumbai experienced a decrease in the pollutant concentration in April, May and June relative to March, showing a declining trend due to the lockdown. Chennai observed a higher concentration of carbon monoxide during the lockdown period than in 2019. That can be treated as an isolated case, that we have to find out what is the reason behind it. That can also be explored. Kolkata witnessed an overall drop of almost 8% in the pollutant concentration compared to previous year. So all the major metro cities have a lesser CO emission as compared to their previous year. Now, we talk about the ozone, the O3. Kanpur comes under the moderately polluted category for O3 pollutant. The overall average of concentration of pollutant for 2020 is found to be 18% less than the polluted level in 2019. The monthly average in the concentration of pollutant in 2020 found to be more than in 2019, and except in June, Delhi O3 concentration was 35% less than the previous year. However, overall increase in the pollutant concentration of about 28% is seen in Delhi. This is for O3 data, but overall when we see, there will be an improvement in the air quality index. Now this is the important table which you can see, and this is the table of the air quality for year 2019 and 2020 for the major cities like Delhi, Calcutta, Chennai, Mumbai and Kanpur. There are many other cities, we can go through that, but these are the mostly polluted cities which we have taken, especially this Delhi and Kanpur. And you can see the March data of 2019, that the air quality index was 218, and this was the monthly average. And for the month of March for year 2020, when there was only 7 to 9 days lockdown, there the air quality drops to 163. So you can see there is a remarkable improvement in the air quality when all the sectors were closed. Now you can compare the data of April 270 to just 143, near about half. For May 238 to 173, and for June 196 to 145. Similarly, if you can analyze the data of for Kolkata, you can see in the month of the April and May, the data air quality was 106 and 107. It was just half, 54, less than half, 54, 35, and 35 is a very good air quality. It's a clean city in the clean air in terms of the air quality, 35. So that is very good number. As air quality should be the lower the number, better the air quality. You have to understand. So you can see all the data for the April, May and June when there is a total lockdown. You can see the air quality is in 2-digit, while when for the previous year it is mostly in 3-digit for major cities as compared to this lockdown year. So there is an improvement in the air quality due to the lockdown. Now, moving from this air quality, the pollutant, the water aspect is also important for us. How our this water quality was there in the lockdown. The basin of river Ganga occupy more than 26% of India's topography, encompassing an area of about 860,000 square kilometer. The lockdown was brought significant improvement in the water quality parameter of the water of the river Ganga. It was first time since 2000 the water quality of Haridwar was declared as a class A, that is means fit for drinking. So you can directly drink the water from the Haridwar. The concentration of dissolved oxygen witnessed an increase in most of the station in the main stem of the Ganga river compared to year 2019, which can be stated. So the oxygen level are improved in the water. So that is very good for us. And a comparative study of biochemical oxygen demand of the river Ganga, taken into consideration the average of March to May of previous year to this year. So we have again compared the data from previous year to this year for the particular month. Now you can see the dissolved oxygen level for the year 2020 and 2019, and blue lines is so in mostly in maximum cities the blue lines are higher as compared to red line. So means the oxygen content were improved during the lockdown period. and for all the stations from Haridwar to Dakshineshwar. In major cities, the blue lines were higher. It means the oxygen level is higher in the water. And the comparative study of BOG, biochemical oxygen demand, that is also given for the all the cities. And so when we talk about the air and water pollution, due to there is a law, and when we talk about the air and water pollution, air and water quality improves due to the lockdown. But there is some negative aspects also. Due to this pandemic, the use of the medical waste, the production of the medical waste goes on the higher side. Including the medical waste, there is an increase in the mask, gloves. So after some period of time, people are going to throw it. And when there is not a proper disposal, that is a very serious threat to our population. So due to COVID-19, a huge amount of biomedical waste were getting generated, which need to be handled and treated carefully as chances of transmission remains after a disposal. India generates about 101 metric tons of COVID-19 biomedical waste per day. And due to the lack of proper knowledge of disposal method, proper facilities and initiative, some of the contaminated waste are ending up in landfills and oceans. You cannot throw your mask on a roadside. That is very important because it will affect not only to you, it affect the whole society. So that is the awareness we have to create. Increasing the spread of the virus and at the same time is degrading the environment. So that is affecting the environment also. According to the report by Worldwide Fund for Nature, inappropriate disposal of only 1% of mask will result in monthly dispersion of 10 million of masks in the environment. And considering the weight of one mask to be 4 grams, this would taint the environment with more than 40,000 kgs of plastics. So it is not only about the mask, it is about the medical waste, syringe and other, all the waste are on a higher side due to this pandemic. And the disposal of the waste, recently DST has floated various schemes how to remove how to free from this medical waste. The project were invited on that theme particular only because it is serious aspects. Now, amount of COVID biomedical waste generated in different states of India, you can see in Maharashtra 17.494 million metric ton per day, in Tamil Nadu 10.41, in Delhi 11.114, Karnataka 2.8, Andhra 5.516 and Gujarat 11.693. And medical waste is not only in form of mask and gloves. There are PPE kit. PPE kit can be used only once. So daily the PPE kit, this photograph show you that PPE kit and other COVID medical waste are at landfill in Gazipur. So that will coming days will affect our society because you can see in this picture, we are living nearby this particular area. So the people who are living in this particular area can be affected by this medical waste in coming days. So the disposal of this medical waste is very important for us. So that is the one negative aspects of this pandemic which we have to address. Now, what are the future direction? When we summarize all this energy, environment and pollution aspect, what are the future direction? The ongoing energy transmission from thermal to solar and other renewable and electrifying mobility has to maintain its shifting trajectory, means we have to moving towards the renewable sector. Annual losses of electricity distribution companies are predicted to be in billions of dollars, and hence the use of innovative technology such as smart metering has become a solution unlike any other. This crisis has demonstrated that government and individual are capable of strong and rapid action in the face of overarching challenge. To keep up the momentum, investment should be in clean energy and public transport, creating more jobs and better environment than traditional investment. Critical importance should be given to expanding access to clean water, clean air, and primary health care. This will improve life expectancy and increase economic and physical resilience. Sustainable development in the energy and environment sector will boost up the economy as well as the morale of the people. So these are some of the points in broad way moving our future direction. So what is the conclusion of the study? What study showed that the thermal energy generation sector was severely hit hardest by COVID-19 pandemic as compared to hydropower. The coal imports reduced by 27.5% compared to last year, along with 23% drop in coal offtake from the coal field. There has been reduction in the thermal power plant generation, which was declined by 29.43% in April 2020, leading to a drop in plant load factor to 42.17. The petroleum product and consumption reduced 15 to 20% and 32% respectively for March and April. Prices of diesel went beyond the prices of petrol for the first time in decade in India. That is the one aspect, that diesel prices were higher the petrol for some period of time. Now again the petrol prices were higher. The stockpiling of COVID-19 related biomedical waste has raised concern over waste disposal and landfill management. And other aspect is that the improvement in the air quality and the water quality are temporary. Again, we are again going back to that poor level of air quality and water quality, because again we started to degrade the environment. We are not taking the measure to reduce the air pollution and water pollution. Hydropower plant shows the less amount of decline as compared to the thermal power sector, and it also play a key role in maintaining the grid flexibility due to sudden change in the load. The air and water quality shows positive trend with the reduction in the concentration of major pollutants such as PM 2.5, PM 10, NO2, O3, and biochemical oxygen demand. The recovery of the environment will be temporary unless a sustainable way of living is chosen. That is the important finding of this study. The pandemic provides an opportunity to make a shift to a clean energy and develop way and method for sustainable living. So these are the reference. Thank you from my side. If you have any question, we can discuss.
Thank you very much, sir, for your very informative session. And I would request all the participants, if they have any question, they can kindly ask, or you can share your questions in chat box. So I guess no one is having any question regarding the session. And so I would like to again thank you very much.
Thank you, sir.
So thank you, sir, very much. Sir.
Thank you. Thank you.
Dear participants, feedback link has been shared in the chat box. Kindly refer to the link and fill the feedback as soon as possible. So thank you again, all of you.
ये उसकी पुली है वॉशिंग मशीन की, जो ड्रायर की पुली होती है।
अच्छा,
सर को कर दिया, सर हो जाएंगे आप? सर गुड आफ्टरनून.
Good afternoon, Dr. Mohit. How are you?
I'm good, sir. How are you?
I'm also fine, thank you.
Okay, sir. Sir, it's 2:30. We'll start in 5 minutes, sir. Let's wait for some more.
Okay, no issue, no issue. I'm ready anytime.
Start at 2:35, sir.
Okay.
Okay, sir.
आपके लैब में हो ही जाएगा.
Brijesh, we'll start at 2:35. Okay.
Yes, sir. चर्चेच्या बडबड केली शिंदेवानी. तुमच्या सांगण्यावर आम्ही आलोय पगार तर झाला नाही तेव्हा.
ठीक आहे.
पाँच से सात लाख होगी। चाय है?